All right, so in order to graph our other trig functions, we are going to use what we know about reciprocal graphs. We know that secant is 1 over the cosine. We know secant and cosine are reciprocal graphs. We also know that cosecant is 1 over the sine. So sine and cosecant are reciprocal functions, reciprocal graphs. We are going to go back to what we did with reciprocal graphs last semester. And then we're going to apply that to the trig functions, but we're going to do them the very same way. Remember, we did things like if we had the absolute value of x, the reciprocal graph would have been 1 over the absolute value of x. So we did things like, oh, there's our graph of the absolute value of x. And remember, we looked at that and said, oh, is there any place where that touches or crosses the x-axis? Yep, right there. So we're going to have a vertical asymptote right there. And then we said, are there any points on that original graph, that absolute value of x, where y is either positive or negative 1? Sure, there are. 1, 1, and negative 1, 1. And we're going to keep those. And then we did our real graph with those asymptotes and did things like that. So give me, hands up. Do you remember that we did these? Maybe you feel a little rusty, but we did those at home too. Do you remember that we did these things? So the critical pieces are touch or cross x-axis, we have a vertical asymptote. Keep anything with a y-coordinate of positive or negative 1. And then figure out, with some plus point checks, which way does it need to go and all of that good stuff. So that is what we are going to do with cosine. Its reciprocal is going to be 1 over cosine of x, or that's how we're going to come up with the graph for the secant. And same thing with sine. Eventually we'll do the same thing with cotangent and tangent. On this slide, and then move on to the next one. So here's one where I simply I did x minus 2 on that, but the same idea that I just talked about. So cosecant of x, we know, is y equals 1 over the sine of x. So I'm going to do a dotted graph for sine because I'm really supposed to graph cosecant. I am not supposed to graph sine in this problem, so therefore it's going to be dotted. We know that sine goes through center line, increasing, and we go up and down to 1 and negative 1. And we have this oscillating pattern right here. I can have my dotted line in here to make it more like what I'm used to. And let's see. Oops, wrong way there on that one. Why is it doing that? Fix it this way. Okay. Got that dotted line going back here, and so it starts going that way. I need to come down here, and then back to my center line, and up here, and back to my center line. So there's my sine graph, except I need some angles on there. It's kind of meaningless if I don't know what the period is. And I'll just do this with the basic 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And same thing over here. Okay, I want to find any places that graph crosses or touches the x-axis, and I'm going to have vertical asymptotes there. So I have a vertical asymptote at negative 360, I also have one at negative 180. I also have one on the y-axis and at 180 degrees and at 360 degrees. So far, so good. The other thing with reciprocal graphs, any point that has a y-coordinate of 1 or negative 1, I need to keep, and it needs to be on my reciprocal graph. So this had a positive 1, and this had a positive 1, so those are going to be on my real graph of the cosecant. And these points, these mins, had a point of, had a y-coordinate of negative 1, so I'm keeping those on my real graph. So far, so good with everybody. Okay, if I am between 0 and 180 degrees, between these two asymptotes, starting on the positive side, is sine positive or negative between 0 and 180 degrees? It's positive. So 1 over that positive never comes down here and gets negative, right? So towards this asymptote, it has to stay positive and shoot up. And same thing here. And you could plot some other points if you really wanted to. If you wanted to do, so let's see, at 45, 1 over root 2 over 2. I mean, you're going to be getting into some weird things with that. But you could keep working your way through that. At 30 degrees, the sine's a half. 1 over a half is 2. So I could even plot that point if I really wanted to. 45 degrees and 2. I'm not going to be requiring you to do that unless we're dealing with an amplitude change or something where we need it in a particular problem. Okay, if I'm between 180 and 360, everybody shout out, is sine positive or negative? So 1 over that negative right here is still going to be negative. So I can't go here and then be coming up above that x-axis where it's positive. So this is going to be a u that opens down. Same thing between 0 and negative 180. Sine's also negative. So 1 over those negatives, I only get more negative numbers. Between negative 180 and negative 360, sine is positive. So once again, I get a u like this, and that pattern would repeat over and over and over again, alternating between right side up and upside down u's. Now, notice, because this is the mistake I see a lot on these graphs, there is the space in between the u's. They do not start at the center line. They don't touch the center line. The lowest these ones that open up goes is 1. And the lowest, the ones that are upside down go, their highest point is at negative 1. You must have these dotted lines and have these numbers labeled. Let's say +1. That dash part of my line made it look like a -1 in there. Everybody good with all of that? Okay, now we're going to do the same thing, but with secant. Secant is 1 over the cosine. So I want to graph secant for this problem. I don't really want to graph cosine. So I'm going to draw a dotted cosine since that's not what I'm really asked for here. So again, if this is 1 and this is negative 1, and I put my dotted lines in there, I know that cosine normally starts at a max, as long as I have had no shift. So dotted, because that's not what the problem really wants. It just is going to help me figure it out. And this time I think I'll do radians, just because we did the last one with degrees. So pi over 2 pi, 3 pi over 2, and 2 pi. And minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. And once again, I look for any place that it touches or crosses the x-axis. So that's going to be right here. Oh, no longer have an asymptote on the y-axis like I did before. And here's going to be an asymptote. And here. And here. Are we good with those guys? Then we look any places on that dotted cosine graph where y is 1 or negative 1. I need to keep that and have that on my real graph of secant. I need to keep this min and have that on my real graph of secant. And this one, and this one, and this one. And then just like before, if I think through, well, is cosine positive or negative? I'm going to get my right side up and upside down u's. Now right here, just because of where I happen to start, I didn't go far enough to get my whole u, but it would really keep going in both directions. So let's look at these two for a moment and make a couple of observations about them. Remember so let's see, normal periods. For sine, it was 2 pi or 360 degrees. For cosine, the normal period was also 2 pi or 360 degrees, right? Since I've got secant up here, how long does it take me to get 2 complete cycles? That means one right side up u and one upside down u. And then that's what repeats over and over. So I had to go from pi over 2 to 3 pi, or from minus pi over 2 to positive 3 pi over 2. Is that still 2 pi? So, same thing for secant. It was still 2 pi or 360 degrees. And was that also true for cosecant? Right side up and upside down, I had to go from 0 to 360, so it was also true there. So sine, cosine, secant, cosecant all still have a normal period of 360 degrees or 2 pi. We still have that space in between. The x-axis is still the center line, and the two that I just did still have an amplitude of 1. I can change those then by putting other numbers in the equations. But the basic amplitude is just 1 unless I put some number in to change it. Notice these look almost the same. Secant has a vertex on the y-axis. Cosecant has an asymptote on the y-axis. So you can either memorize that, or you can do enough of the dotted sine, cosine, reciprocal graph each time. Which one is this? Which way does it go? Does that much make sense so far? Okay, tangent. I've shown you a tangent graph before. And tangent and cotangent, yes, are reciprocals. But if we haven't learned either of the graphs, we can't do a reciprocal method on that. So I'm going to go back to the very, very basic method. First time I'm graphing something, I want to plot points. I have written down 90 degrees, pi over 2. They're one and the same. I don't really care which you use. And I put in 180 degrees and 270 degrees and 360 degrees and so on. And I am going to label that this is 1, 2, 3, and negative 1, negative 2, negative 3. Okay, hopefully we've been memorizing some of those tangent values on the unit circle. Tangent of 0 degrees is 0, so I'm going to plot 0, 0. If I am at 90 degrees, Oh, that one's kind of a pain. Tangent is undefined. I've got to have an asymptote because it's undefined. If I did it as sine over cosine, I'd have it over 0. So that's why I have my dotted line there at 90 degrees, negative 90, and so on. Okay, if I go to 45 degrees, the tangent of 45 degrees is 1. So I can plot 45, comma 1. If I go to negative 45 degrees, the tangent in that fourth quadrant is negative 1. So I can plot negative 45 degrees, negative 1. If I am at, that's probably enough to start seeing the pattern. It's got to be going down and getting closer to that asymptote, and going up and getting closer to that asymptote. Notice the concavity here. This side opens up, but this side opens down. You will talk next year, and I'm not going to really talk about it other than today, but this is what we call an inflection point, because it changes from concave down to concave up. Inflection points are where they change which way they curve. So that looks kind of like a piece of a y equals x cubed graph. Different points, but kind of looks the same. To kind of help remember what's going on with that. Okay, if I did some more points, the tangent of 180 degrees is also 0. Tangent of 270 degrees is undefined. Sine over cosine would be 1 over 0, so I've got my vertical asymptote. Tangent of 135 degrees would be negative 1. Tangent of 225 degrees would be positive 1. And so I'm going to have another one of those squiggly things. And another one. And another one. And another one. And so on forever and ever. So are you okay? That's basically what a tangent graph needs to look like. Okay, a couple of things to point out on that. Notice I put my dots on these ones and negative ones because that's how I show amplitude on a tangent graph. We're going to have some where the amplitude's 2, and you'd have like 45, comma 2 instead of 45, comma 1, and things like that. So you've got to carefully plot those dots, not just a quick scribble and go on. What about the period here? How long does it take to do a complete cycle? A complete cycle is just one of those squiggles, right? Robbie? If I go from negative 90 to positive 90, I have one whole squiggle, right? So tangent is different. Its normal period is only 180 degrees, or pi. Now I can do cotangent as the reciprocal of this thing to figure out what it's going to look like. So now let's do the cotangent one, and so I've already drawn tangent in here with my dotted lines. I have also said, oh, the tangent graph touches or crosses the x-axis here, and here, and here, and here, and here, so I have these vertical asymptotes. Oh, I need to keep my 1s and my negative 1s, so I need to keep, if this is 1, and this is -1, this point, and this point, and this one, 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 and this one. And I'm going to try to plug in just a little bit to figure out what's going on here. So let's see. For cotangent, let's see, cotangent of 90 degrees, that's cosine over sine, right? And cosine of 90 is 0 and sine is 1. So, oh, I actually have the 0 point on there. So when I draw this one in, it's got to go that way for that little section of it. And this way looks like a reflection of the squiggly shape that I had before, right? It is, so on this one, each section was increasing. But when I come over here to this one, I get a section that is decreasing. And then let's see, at 270 degrees, if I plug in cosine 270 over sine 270, I get 0 over -1, so I need 0. And it's got to go through this keeper point. So I get another shape that looks like that. And same thing for these other sections. If I evaluated cotangent of -90 and cotangent of -270. Notice again, I changed concavity from opening up to opening down. But notice one thing that is a little bit different. Where tangent had a vertical asymptote, cotangent is 0. Where tangent was 0, cotangent has an asymptote. So the asymptotes are not the same. With tangent, the asymptotes were at 90, 270, and so on, and I went through 0, 0. For cotangent, I have an asymptote at 0, 0, and at 180, 360, and I have zeros at 90 and 270. Does that kind of make sense? So you want to remember, you want to memorize tangent is the increasing, cotangent is the decreasing, and then you can kind of plot a point. Let's see, what happens with 0? Is it an asymptote or is it 0? Oh yeah, that's how I set this one up. Cotangent, the period, is again, so let's say we went from 0 to 180. So the period is again 180 degrees or just pi. So now you know the basic shapes of all 6 trig graphs. Sine and cosine are the sinusoid waves. Secant and cosecant go back and forth between right side up and upside down U's. Tangents and cotangents are the squiggles that look kind of like y equals x cubed or y equals minus x cubed. And then just figure out where the asymptotes and zeros and everything are with them. Okay, there's a little bit more that we're going to do with this today. This is actually, I think, the easier part. So we want to come up with an equation here. So it's going to be sine, cosine, secant, cosecant, or tangent, cotangent. That's the easy part. Let's narrow it down to 2 we need to choose from. Max? Is this possibly sine or cosine? Cosine does like this. Aliana? It's going to be either secant or cosecant, just because it is right side up and upside down U's. It's got to be one of those two. So then we're going to try to figure out which. So one of the things that I'm going to do, here's my y-axis. Oh, if I started trying to draw in a reciprocal graph, it would have to look like that. Which reciprocal graph has a max on the y-axis? Cosine has a max, so this would have to be 1 over cosine, which is, so this thing would have to be 1 over cosine, so we know we're dealing with a secant graph. Okay, then notice we have the space between the maxes and the mins on these u's. So this one right here, and it was a little bit hard to see on here, this is a 5 right there that they've labeled. And this one right here, see if that's a -5, that's a -1. So if I were doing cosine, the max would be at 5 and the min would be at -1. How far apart are those? 6. So my amplitude needs to be 3, and my center line needs to go halfway between that -1 and that +5. So my center line needs to go at 2. So that tells me this equation needs to be y equals center line 2. I did it with a plus cosine graph. So it is now a plus secant graph with an amplitude of 3. And my variable that they labeled over here was x. So amplitude and center line come from what would have been the amplitude and center line of the sinusoid that we're taking the reciprocal of. Thumbs up, thumbs down at home. Are we good with that so far? What about in class? Anybody have a question? Let's do another one. What? Those didn't clear? Hang on. I haven't used that yet this year. I don't know why it didn't clear from last year. Okay, we'll try this again now. Okay, again, let's narrow it down. Are we going to be talking about sine, cosine, secant, cosecant, or tangent, cotangent? When you have right side up and upside down u's, Parker. Well, right now, just right side up and upside down u's, it's either secant or cosecant. And then we're going to figure out which. But the u's are always secant, cosecant. So to figure out which, I say, well, if it were a sinusoid, it would have to be doing like that. So it would have to cross my y-axis at wherever the center line is, and I'll figure that out. I don't know if I do it real accurately or not. But it would have to cross my center line, and my y-axis at a center line increasing. Center line increasing, Anna, is positive or negative sine or cosine?
Positive sine.
So we're looking at 1 over positive sine, and 1 over sine is cosecant. So we are looking at a positive cosecant equation for this thing. Okay, let's get rid of what I put in there that I wasn't being real accurate with. And now let's be a little bit more accurate with max, min, and center lines for this one. So my maxes would have to go right there. My mins would have to go right there. And my center line halfway in between. So let's see, if this is -5 right here, that means each tick mark is 1. So the max for the sine would have been -2, and the min would have been -6. How far apart are those? 4. So the amplitude has to be 2. And the center line has to go 2 above the -6 and 2 below the -2. So that means it needs to go right there. It'd be 2 below the -2 and 2 above the -6. My center line needs to be -4. Everybody okay with how I got that? That means now I'm going to put it all together. Y equals center line -4 plus cosecant, so plus amplitude 2, cosecant, and again they have an x over there, so -4 plus 2 cosecant x. Let's try one more here. Okay, so everybody tell me, is this going to be sine, cosine, secant, cosecant, tangent, or cotangent? That one is going to be tangent because it is the increasing. It looks, remember, tangents have pieces that look like that. Cotangents have pieces that look like that. So we need tangent for this one. Okay, now we need to look on the tangent and cotangent graphs a little bit more carefully. Where are those inflection points? Where does it change from upside down half U to right side up half U? This one happens to be on the axis. So we do look at those inflection points. That is my center line. So for this one, my center line is 0. Is my period still the normal period for tangent? Is it still 180 degrees? So from -90 to +90. Okay, so my period's still 180 degrees, so I don't have to worry about any changes with that. So since my period is still 180 degrees, I am going to look at the 45 degrees, or the pi over 4. So at 45 degrees, I have this point right here. I have 45 degrees, comma, 3 for y. So if I just say y is 0 center line plus tangent of x, I'm not going to have something that's true. Because if I plug 45 degrees in, tangent of 45 is 1. And I need 3. I have to look at that 45 degrees. That means my amplitude is 3, so I have to put a 3 in front of that tangent. Not enough to just say, oh, it's the plus tangent shape. You've got to check some coordinates in there. I think I just have one more of these. And I think we're done. Let's see if that's true. Yep, just one more. And, well, I may give you guys a couple to try to come up with on your own of what you think they are. But just one more that I'm actually doing here. Okay, so let's see. John, can you unmute and tell us, do you think this is going to be sine, cosine, secant, cosecant, tangent, or cotangent?
Cotangent.
It's going to be cotangent. See how this one is going downhill on each little section. So we know this one needs to be a cotangent graph. We're going to look for the inflection points. And again, still being nice to you because it's the first day, the inflection points are still on the x-axis. So that means my center line is still 0. let's look at one of the 45s. If the amplitude is 1, the cotangent of 45 degrees would just be 1. But can you see that clearly enough, Rebecca, to tell me what the cotangent of 45 is on this graph? 2. So because I had 45, 2, that means my amplitude is 2. So I put it together. Y equals 0 plus 2 cotangent x. It'll get harder in future lessons where we have had more of the shifts and other changes and things. Questions from anybody? All right, you guys all give it a try here. So you see I've got 2 of them right here. So part A and part B. And so write down what you think the equations need to be. What's the center line? What's the amplitude? Sine, cosine, secant, cosecant, tangent, cotangent. So at home, you can do the best that you can to type that into chat. Just do y equals for A, and then do a comma, and then y equals and do the B one.